Welcome to Developing Software with Micromanaged Driven Development and Kiro CLI. Just as compilers abstracted machine code, GenAI abstracts software development into natural language. That's the shift this course is built on. Working with GenAI introduces new challenges. Non-determinism means the same prompt can produce different results each time. Hallucinations mean the model can confidently generate things that are wrong or don't exist. Error spirals happen when the AI tries to fix one mistake and ends up creating more. And token cost means every interaction has a real measurable price. Micromanaged Driven Development was built to minimize these challenges. It's a super prompt I've been reusing successfully since June 2025 across countless projects, from hackathons to mission-critical software. Micromanaged Driven Development is tool and model agnostic, meaning in the same project I can use it to generate code with OpenAI's Codex, Gemini, Claude Code, or AWS Kiro, which is the one we'll be using in this course. Micromanaged Driven Development rests on three key principles. Small reviewable steps mean you never approve more change than you can actually understand. Documenting AI interactions creates a clear record of what was asked and what was generated. And every change is your decision. The AI proposes, but you're always the one who approves. So, what are we going to build? A photo gallery web application using React. Besides the usual development stack, React, Node, and Kiro CLI will need version control, for which we'll use Git. We also have two completely optional tools that'll help us move and visualize things faster: a Kiro steering file and Obsidian with the fancy Kanban plugin. The first step is to set up Kiro to use MMDD. We go to mmdd.dev and click Copy on the first line of the quick start. Here we have the terminal in an empty directory called Gallery. This is where we'll work. We paste the command we copied from the website and press Enter. This bash script will download two markdown files, save them into a new directory called dev_log, and set up the steering file for Kiro if Kiro is detected. Then we go back to the website and copy the second instruction, which is a prompt we'll use in Kiro. Back to the terminal, we run Kiro and paste the prompt we just copied. Instead of using one huge one-shot prompt, the main idea behind MMDD is that we generate markdown files that contain the prompt we'll use. The file we just downloaded, 00_mmdd.md, contains the super prompt. And right now, Kiro is using that same prompt to guide us as we plan our project. Once Kiro reads 00_mmdd.md, we describe what we want to build, an app called Gallery in React. This gallery has two views, one that shows the images in a mosaic and another that shows a map of the world, with pins placed using the image's metadata. When the user clicks on a pin, the app displays the images related to that location in a modal dialog. We describe the app to plan the work to be done, which is organized into units, major phases or components, optionally split into subunits, discrete build moments. Note that there's a dialog with Kiro, whose purpose is to make sure that we're both aligned. Here, Kiro is showing us a potential plan with 4 units. The first to set up the project, then the data, and lastly 2 more units to implement the different views. Then we're asked for the photo locations. We'll use photos on our disk. The tooling suggestion is correct, and so is the suggested map library. Kiro gives us a draft. We review it, and once we're happy with it, we ask Kiro to save the file, which will be saved in the dev_log directory, along with the other MMDD files. Note that the file with the plan will be called 00_main main.md. The 00 means we're following a sequence. 00 is for the foundation files and the plan. The first unit will have the 01 prefix, the second will have 02, and so on. If we look at the content of the dev_log folder, we now have 3 markdown files. We'll use Obsidian to read them. We open the gallery directory as an Obsidian vault and then open 00_main.md, which is the file that contains the plan for our project. Using Obsidian is completely optional. We could use any markdown viewer or IDE like VS Code. In this case, we use Obsidian because we're listing the units using a fancy Kanban format, a markdown block that lists our units in a table. We open it with the Obsidian plugin Fancy Kanban, which renders a beautiful Kanban board that helps us keep track of the status of our project. Before doing anything else, we initialize a Git repository. There are many benefits to using version control. One of them is being able to move back in the project history if things go wrong. Then we plan Unit 1, which is about setting up the main stack for the app. We always start by asking questions. In this case, whether there is anything to decide. The point of asking these questions is to make every decision explicit, so we keep the judgment ourselves. Once we answered the questions and there's nothing else to discuss, Kiro writes the file for Unit 1. This file represents the prompt that Kiro will execute, a constrained scope reviewed by us. Once we're happy with the plan, we ask Kiro to implement it. At this point, Unit 1 has just set up a plain TypeScript React app. We test that everything is in order, and then we ask Kiro to commit the changes. For Unit 2, we repeat the flow. We start by asking for decisions to be made. We fill in the gaps, and we review the unit definition before we start the implementation. The key to generating reliable software is to validate what Kiro is generating. Manual functional testing and asking Kiro to write automated tests is one of the best ways to ensure the software is doing what we expect and that new modifications won't break it. The moment to do that is before closing every unit. We won't do it in this course, but it's highly recommended for software meant to be run in production. And we repeat everything in Unit 3. We check for gaps, we define the plan, we ask Kiro to implement it, we test and review, and when everything is okay, we commit the changes. Same for the map view. Check for decisions, write the unit, implement the unit, review, and complete the unit. Here we have an example of why it's so important to reduce the scope and also to verify every step properly. This implementation has two issues. The first one is that the GPS coordinates are completely missing. They're in the files, but for some reason Kiro didn't get them. The second issue is the pins. They're duplicated and they don't look like pins. Now that the Unit 4 implementation is working as expected, we close the unit. This project has just one pending unit, which we'll leave as an exercise for you to do. Continuing a project made with MMDD starts by asking Kiro to read all the files in dev_log, as simple as that. If we go to 00_main.md, we have the Kanban board updated and the entire log of the project documented in each unit's file. As you can see, every time we close a unit, Kiro saves a file with the _done_postfix, where the main implementation details are documented. Then, if we visualize the project in GitHub, we can relate every unit to one commit. And that's MMDD in practice. Small, reviewable steps, documented as you go, with every decision staying yours. Even when working with a powerful agent like Kiro, you saw it catch a real issue along the way, which is exactly the point. The project has one unit left. Try finishing it yourself, using the same flow we just walked through. You'll find everything at mmdd.dev. Thanks for watching.